and other applications. So let me welcome all of you. So our National Vice President, Dr. Raghav Sharan is here. So Honorable National Vice President of ISAS Headquarters. And also we have a webinar committee chairman, Dr. P.V. Joseph. And we have the vice chair, the National Webinar Committee vice chairman also, Professor one second. Joshin, and also our Department of Chemistry, Rani Chennamma University Chairman Professor Baswaraj Padmashali. And I would like to welcome all the office bearers and the previous the chairman and of the ISAS headquarter and all the advisors and the executive committee members and the all the chairman and all the office bearers of different ISAS chapters from different chapters. So I would like to welcome one and all for this national webinar. Now I would like to introduce today's speaker. So that is Professor C.V. Elamgad. So he is a scientist of eminence and also professor at the Center for Nano and Soft Matter Science, Bengaluru. So he actually his area of research is on soft matter, nanomaterials, and composites and other closely related functional materials, promising from BASI, and he has been working on basic research too and advanced science and technology viewpoint on these materials. Actually, he is also an adjunct faculty at Dr. T.M.A. Pai Endowment Chair in Advanced Functional Materials at Manipal Advanced Higher Education Institute, and also is a Professor C.N.R. Rao Distinguished Chair at SGBIT, and he is also a professor at this one, what is that? Academy of Scientific and Innovative Research Center. This is a CSR laboratory, in fact. And yes, he's a, yes, many credit is not this one. And he has done his MSc and PhD from Karnataka University, Dharwad. Later, he was also a postdoctoral researcher at Department of Organic Chemistry, IISc Bangalore. And later, and also he was a postdoctoral fellow at Taiwan National Chio Tung University. And subsequently, he was a senior scientist in private chemical industries before moving to the SENS, that is the Center for Nano and Soft Matter Sciences, Bangalore. He worked more than about some 25 years. And he has made many noteworthy scientific contributions in liquid crystals with his, with his journal research publications, more than 250, and besides a 10 national and international patents to his credit. He has guided over 9 PhD students, 5 postdoctoral researchers, several project assistants. He has been a principal investigator for research projects sponsored from different government agencies. His scientific accomplishments have been well recognized at the national and international levels. So he has presented over 400 invited talks at the various platforms, and he has published in most leading international journals, and his citations are more than about 5,700 or so. And he has been a invited scientist to various countries, and he is a recognized research guide of at Mangalore University and also at the CSIR laboratory. Yes, sir. And he is some of his what that public that awards include he is a Bharat Ratna Professor C.N.R. Rao Distinguished Chair Professor at SJBIT Bangalore, and also he is a uh, secretary for this Chintana Rasayana Sanstha, Vidysagar University campus, West Bengal, and he is very closely associated with Indian Liquid Crystal Society, and he was a vice president of Royal Society of Chemistry, U Deccan section. So like this, he has got received many awards, including this GST and GSPS fellowship. And he was also very, Sir C.V. Raman Young Scientist Award given by Government of Karnataka. And MSR, the Material Research Society Award, also he received recently. And many such awards. So he has been listed among the top 2% scientists, listed by this Stanford University. He has been elected vice president, as I said, Royal Society of Chemistry, Deccan section. And he has been, very active in educating college students, teachers about liquid crystal science and technology. And he's throughout, inspiring talks at various refresher course and science popularization programs. I think with this introduction, I request our Honorable President of ISAS to say a few things on this national webinar, followed by the talk from Elamgad sir. Yes, over to Sharan sir.
Okay, thank you. ISS friends, Dr. Nair and Dr. Pillai, patron and past presidents, esteemed guests, and fellow researchers, welcome you all to today's webinar on functional soft nanocomposites and their applications for invisibility and others. As the president of ISS,
recording in progress,
I'm honored to welcome our esteemed speaker, Dr. Yella Magat. Soft nanocomposites, due to their unique properties, have revolutionized various fields. The concept of invisibility, in particular, has fascinated scientists and engineers, and we are excited to explore its possibilities. Nanocomposites can be engineered to bend, absorb, or reflect electromagnetic waves, including light, to create cloaking effects by creating materials with specific refractive indices, essentially making them transparent to certain wavelengths of light. Their large surface area and tunable properties allow for high drug loading capacity and controlled sustained release to specific sites in the body, as they can mimic the structure and properties of native tissues. They create a scaffold for tissues regeneration in tissue engineering and several other areas that, such as electronics, aerospace, environment, and others. Our speaker will share insights on the latest advancements and future directions in this field. I appreciate the efforts of webinar committee for organizing this event and bringing together experts to share knowledge. I must appreciate Dr. Manjanna, chairman of Belagavi chapter, for organizing today's webinar in collaboration with Dr. Joseph, chairman of the webinar committee. Let us engage in productive discussions and explore the possibilities of functional soft nanocomposites. I request our eminent speaker, Dr. Yella Maggad, to share his expertise and enrich our knowledge on the topic. Thank you.
Thank you.
Thank you, sir.
Good evening, each and everyone. Am I audible?
Yes,
sir.
you are audible.
Yes.
You are audible.
In the first place, I would like to express my gratitude to Professor Jayappa Manjanda for speaking about so nicely, and also he's the main person to invite me to bring myself to this particular platform, which is a very unique and a very esteemed platform. It's a great honor to be here and say something about what is being done during the last 10 or 15 years in my laboratory, my own laboratory at the Center for Nano and Soft Matter Sciences. Well, at the outset, I would like to express my deep sense of gratitude to Indian Society of Analytical Sciences, ISAS, for giving me this wonderful opportunity to interact with you all esteemed, distinguished professors and researchers. I would like to acknowledge the great recognition of me by ISES for having invited me to be on this platform. First, I would like to thank Dr. Saran, the national president, and Dr. Joseph, and Professor Manjana, and others for giving me this wonderful opportunity. Well, ladies and gentlemen, today I'm going to speak to you on one of the fascinating aspects of science called invisibility. Well, first of all, I would like to say about my name. My name is very strange. It appears to be Gada, Yeda Gada. Sometimes people call me Gada also, but that is not the case. I am from Godalgoda, near Bagalkot, Hubballi. We are weavers. Basically, we are weavers. We have 7 looms at home. So
Oh,
7 looms is called Yeda Maggada in Kannada. Yeda Maggada. So many people call me Gada. It's okay for me. Okay. Now, today I'm going to talk to you about, uh, invisibility. Well, I've been able to figure out right from my childhood that there is something in me, or I would put it this way. I went on asking a very strange question to my parents, my teachers, and till today I have been asking the questions to myself and others and my colleagues. The first question I put across to my teachers, or rather to my parents, you all are saying God is existent. Not only we, you take any religion or anybody on this earth, their parents would have taught them the existence of the God. I think all of you will agree with me. Doesn't matter from which religion you are, whether Hindu, Muslim, Jain, Sikh, all the parents and grandparents would teach us, okay, get up in the morning and salute God. First pray God and then proceed. When that was the case, when my mother was so insistent to me, you should pray God all the time. Then I went on putting the question to my parents, why God, if that is the case, show me. You show me the school, you show me the market, you show me my grandpa, you show me my mother, you are showing me my father, everybody. But where is God or goddesses? That was a question I went on asking. Ladies and gentlemen, I'm very happy to let you know that I could find answer myself today. What's happening? What is it? It's all about science and technology, my dear friends. See, this is my perception. As a scientist, I have my own way of looking at the things. I may be right or I may be wrong. I'm spiritually connected as well. Now, I have looked at this point from spiritual point of view as well as scientific point of view. The spiritual masters or the scientists are arriving at the same point. Why God is not visible to all of us, whereas He's visible to some saints, some spiritual gurus, or some special people like perhaps all of you. You must have seen. Some of you have seen. At least I believe the existence of God, what is known as cosmos energy. What is it all about? Why you are not able to crack this question, ladies and gentlemen? I have little bit of understanding after working about 1.5 decades or so. I have been able to, address in some sense. I will not take you to my kitchen. I will not tell you what is exactly the synthesis. I will not show you the test tubes, burettes, all that, and round bottom flasks. But I would tell you what I have done and what is it that inspired me to get into this field. Once again, I would like to emphasize on the point that I have been able to understand the existence or invisibility of God and Goddess. What is it all about? In the first place, ladies and gentlemen, let us understand why one is able to see the things around you, whether me or you. With a due respect to blind people, we have been able to things around us. Why? There are a few elements here. I would think in terms of science and technology, and then I'll come to the spirituality, how we are able to see things around us right now. Besides you, many God and goddesses are sitting with you, but why you are not able to see? There is an answer for that. Scientifically, I can address this question. Or scientifically, I can prove that if you do something, you will be able to, see the god and goddess, what it is. That is from the spiritual point of view. But scientific point of view, you need to do some experiments. What are those experiments? That I have carried out in the form of, material science. That's what I'm going to talk to you, ladies and gentlemen. Well, a little bit about myself. I'm coming from, I've been working at Center for Nano and Soft Matter Sciences. This is an autonomous research institute under the administrative control of Department of Science and Technology, Government of India, proud nation and Government of India. My name is Yeda Maggad, Yeda Maggada, Yedu Maggada, Yeda Maggada. We had 7 looms, therefore my name is Yeda Maggada, not Yella Maggada or Gada or something like that. Well, now I'm working as a distinguished scientist. DST has reappointed me as a distinguished scientist. I take this wonderful opportunity to Government of India for having done this one. It's a great honor and privilege to accept, and I continue to work as distinguished scientist, ladies and gentlemen. Well, these are my different avatars, and have been working in different organizations in different roles. Well, apart from that, I have been able to, train children and train teachers of all, classes. I have been able to train them how to teach, how to, give hands-on experience to the children, especially the children starting from first standard to say up to SSLC. I would say very boldly that if you want to see a bright India future, the training should be given to the students from first standard to 10th standard. You need to give them, I'm scientist today, it's because of the hard efforts put by my primary school teachers. I can name them. There should be some experimental, demonstrations, chemistry and physics. Therefore, it inspired me to become a scientist. And till today, I strongly believe that there is so much to learn in science and technology. And I continue to do that. And I hope all of you will bless me and wish me good luck to continue to do good research. Well, I declared, as I declared today, I'm going to speak to you on one of the fascinating aspects of science, invisibility. Right? Uh, Before I get into the discussion, so we have been able to achieve 2 types of material. It is extremely simple. As you can see here, we have been able to realize 2-dimensional coordination polymers. These are called supramolecular coordination polymers. As you can see, we have taken simple experiments. We have taken tetramines and taken the metal ions having oxidations +2. And then the moment you treat them, it's like a titration, like just like take 2 test tubes and add them, your material ready. You can make in terms of grams and kgs, and these have wonderful properties. I shall discuss about it for a while, and then I'll move to my main subject. On the other hand, ladies and gentlemen, you have what are known as, today's topic is soft nanocomposites. All of you know that nanoparticles are hard materials. On the other hand, you have a new term to listen to me or understand: liquid crystals. Liquid crystals are fundamentally organic compounds. They have special features. They exhibit the properties of both, liquids and solids. For example, they flow like liquids. At the same time, they show what is known as double refraction phenomenon. Okay, that reflects in the form of birefringence property. So with this, meaning that the nanoparticles are hard substances, very hard substances, very, very hard. Although they are particles, they are very, very hard substances. Whereas on the other side, you have organic molecule which flow like liquids in their mesophase and show double refraction. Now, liquid crystals have n number of optical properties. For example, because of their very interesting optical properties, we have been able to use them in various displays called liquid crystal displays. Right now, whatever display you are using, mobile phone display or your computer display, whatsoever, now cathode ray tubes are being replaced by what is known as liquid crystal display. This is possible because of the very interesting characteristics or optical properties of liquid crystals. Likewise, nanoparticles also exhibit, n number of optical properties. Now, the idea came up to me or to my student: why not we combine the properties of hard nanoparticles and liquid crystals. It came up to our mind about 10, 15 years ago. It was not easy, ladies and gentlemen. Nanoparticles are very hard. They are ultra-fine hard materials. They are very fine species, whereas liquid crystals are very soft. Now, the chemistry plays an important role. How can you combine a hard material with a soft material? Now, let's take a butter and sand powder. Can I mix them? No, there's a phase separation. This cannot go together. But when you get into your chemistry or get into your chemistry, this can be done. I'm very proud to say that this we have done. What we have done is, you know that the nanoparticles are generally passivated with NH2 group or SH or COH. You want to make nanoparticles, it should be passivated. Otherwise, they come together, get agglomerated. Again, you are back to square one, where you have metal nanoparticles or metal oxides. Now, in order to keep them in nano size, ranging from 1 to 100 nanometer, what we need to do is you need to passivate these nanoparticles with organic ligands. This is general way of doing it. So what we thought was, instead of using just long chain amines, why don't I use liquid crystals? That's what you see, ladies and gentlemen. My cursor is visible to all of you. Am I audible to all of you? Yeah.
Yes, sir. Yes.
Yes, sir.
Very much.
Okay. My cursor is seen, sir. My cursor.
Yeah. Yes. It is in.
Yeah. See, now what you see is at the center we have centrally we have gold, particles. It's one gold nanoparticle around which there are liquid crystals. Ladies and gentlemen, please note that liquid crystals are associating with, it's not a physical mixing. They are bound to central gold scaffold. You can see NH2 is attracted. See, this ultra fine, this nanoparticle is, electropositive, sort of electropositive, and you have amine. So there's a nice interaction between, nanoparticles and, liquid crystals. They are thoroughly bound now. What is the kind of bond they have? This question yet to be answered. No one knows. But if you have gold nanoparticle, this can be passivated with long chain amines, or you can, in place of amines, we replace it with the amines which show liquid crystal properties. Ladies and gentlemen, I'm very happy to let you know that this sort of exercise, which we put forward, which we have been carrying out, this kind of experiments we are carrying out since about 10, 15 years. And I'm very happy to let you know that we have a number of interesting properties. One among them can address what is known as invisibility. Well, to be precise, the material we have synthesized, they show what is known as epsilon near zero value, that is E and Z property. Well, now let me begin the topic of my today's presentation. I would like all of you to think carefully what I'm saying, and so that you are prepared with the question. What is it all about invisibility? In order to understand what is invisibility, let us try to understand what is visibility. As I said, ladies and gentlemen, right from the beginning, right from the day we have come out of the womb of our mother, we have, with a due respect to blind people, we have been able to see things around us. Let us try to understand what do you mean by visibility, or why you are able to see the things around you. It is extremely simple. Well, around us, light is there. Now I'm sitting here, or all of you are sitting there. Light is there. Light is falling on us. That's the first parameter to be, that's first parameter to be considered. The second one is what light does. That's another parameter. Then third thing is the light which is coming on us, what does it do? And then another parameter is your eyes. Now, let's say that if you close your eyes, can you see anything? No, you are not able to see anything. So now let me, address these things one by one, and let you know what is visibility is all about. What do you mean by visibility? Well, so light which is falling on us will get scattered and reflected. The scattered light will come to your eyes. Now, suppose that if you close your eyes, It won't happen. You will not be able to see. So you should keep your eyes open. So now you are able to see me in the small window. It's because light is falling on me. The light which is falling on me getting scattered or reflected, therefore one would become visible. Now let's say that I suddenly put off all these lights, you'll not be able to see me, meaning that the light which is falling on objects or subjects, subjects means living system. So therefore, the light which is falling on objects or subjects is getting scattered or reflected. Therefore, ladies and gentlemen, we are able to see each other. That's extremely simple. Now, when you think of invisibility, what should happen? This should be reversed. What do you mean by that? When light is again, visit the definition of visibility or understanding of visibility. You or I or any object, if the light falls on any object or subject, light gets scattered or reflected, that comes to your eyes. Therefore, you are able to see things around. That's called visibility. Right. Now, can I, if I want to become invisible, what is invisibility? A person or object or subject is physically there, but you are not able to see it. That's called invisibility. Seeing is visibility, although physically something is there, but you're not able to see it, meaning that that is invisibility. Physically, one would be there, or the objects are there, or subjects are there. That is not ad gochara godila, kanni kanodila. You are not able to see. That is called invisibility. Now, how do I do that? Although physically you are there, but you cannot be. I'll make you to invisible, or I'll make you to disappear. It appears as if you have disappeared. You are not disappearing from there. Now I'm sitting on this chair. I'm presenting a talk. Now you will be able to hear my voice, not myself. So that is called invisibility. I should not be seen by you, although physically I'm present. So this is, from scientific point of view, is a very interesting topic. This has been achieved. Definitely, it is being achieved. So let me go one by one. I'll not, as I said, I'll not get into the kitchen. I will show you how one can achieve this. Okay. So in order to achieve this, what need to be done is, there are two things to be done. What? The light which is falling on any object or subject should be interact in such a way that it won't scatter. The light which is falling any object or subject should not scatter or reflect. Then we are there. Invisibility, I'm repeating again, visibility means the light falling on any object or subject is getting reflected and scattered. Light scattering makes you to see something. It could be anything around you. Can you stop scattering of light? Although you are there, can you make yourself something? Okay, you don't reflect the light. Sorry, you don't scatter the light, or you don't, reflect the light. So that is the experiment is being done. What are those experiments? There are two important experiments one can do. The scientists in recent past, during the last 10-15 years, have come up with a beautiful idea. If you want something to be invisible, there are two experiments or two characteristics you should figure out from a material. What is that? So that the scattering will be stopped. What is that? You have heard about scattering, you have heard about the refractive index. You have water, you have oil, you have air, all of them have positive refractive index. Now, scientists have made materials that have a negative refractive index. I'll come back to this point a little later. Another thing that one would achieve this particular, phenomenon by realizing materials, they have an ability to, show property called epsilon near zero. So the materials which have the ability to show negative refractive index or ENZ property, epsilon near zero. I think some of the physicists, you know what I mean. If material have these two characteristics, then this is possible. We have shown that this is possible. That too, it should happen in the visible range. Well, you can cover all the spectrum of the light, but if you can do it in the visible range, it must be happening in the nature. And if you can achieve this in the visible range, ladies and gentlemen, we are there to experience what is known as invisibility. Well, I'll take you to a small journey up through some videos and some concepts and some movies so that we understand this. As I said in the beginning, I will not take you to my kitchen and bore you. I will show you some of the videos made. I'll show you some of the concepts or some of the stories said by the saints. Then we'll put together, we'll see what it is. Am I audible to all of you?
Yeah.
Yeah, thank you. It is loud and clear?
Yeah, it's very clear.
Yes, thank you. Well, in the first place, I would like to thank all my, associates, researchers who have contributed significantly, to this area. These are the one. This is our center at the back. What you see is in the new center. We were in Jarhalli. About since 4 or 5 years, we have shifted here, and we are in very, very isolated place, and we are very happy to be here. And our health have been improved significantly. We are quite away from the city. Well, I should also take this wonderful opportunity to profoundly thank. I don't know what are those markings, green markings. It's by me. What are those green markings on the screen? You are able to see green markings?
I think somebody
No,
has done
no such
something.
green markings are there.
Green marking is
fine.
there.
It is looking fine.
Yes, sir. Fine, sir. Okay. Okay. See, I must. It's my sincere duty to thank all my, funding agencies. Sense has given me huge money, and then during my promotion, they gave huge money to me because of my performance. They were to give huge money to me, and then Dr. Tame Endowment Chair, although it's a private university, I think you know that Mahe is third rank, so they have been able to give me 20 lakhs this year, and then SCRB has been giving me so much of money, and then CSIR, Tata Steel, and so on. So these are the major, funding agencies. I must thank them profoundly, without whom I would not achieve so much. Thank you, all of them. I'm especially thankful to my government, Government of India, proud nation, for encouraging me to do good research. I'm really, really grateful to, Indian government. Thank you. Well, globally, there have been, concerns and challenges. We have a n number of challenges in science and technology. To begin with, we have a problem in future. In about 5-10 years, we'll be running out of potable water. This is one of the major challenges we are going to face. Although there is a flood, but drinking water we are running out. We should address this problem immediately. We scientists, at least I as a scientist, I'm really ashamed to share that we have been not able to address these concerns. And the next concern is food and agriculture. Given the kind of explosion of a population in India, we have to work on what is known as food crisis. Day by day, our foods are full of toxins, pesticides and so on. Ladies and gentlemen, you may appreciate this point. Although we have reached the moon, we have gone here and there. There is a tremendous growth in science and technology, but we have been not able to make someone to stop eating toxins. The rice we eat, whatever the food we eat, is all toxins. It has some percentage of toxins. I think all of you agree that we have been not able to address this concern at all. It's a shame on scientists that we have been not able to address the food and agriculture sectors. If some bright student like me, no one told me that there is a challenge in agriculture, I would have gone to agriculture. No one told me. But right from the beginning, there has to be training to our students at the primary level that we should work on, food and agriculture. If you take any leading, nations, especially China and Thailand, others, you see the kind of the way they address this issue, food and agriculture. I've heard that they have been able to produce very good food. Now, next comes shelter, is another big issue. Then comes health. As a scientist, as a professors or distinguished professors, we understand how important it is to look into health issues. When COVID-19 stuck, when COVID-19 came, we were really in trouble. We were really in trouble. All of us were really struggling. Finally, you could find some way, but that is not very convincing. Then the safety. We are not safe. And then energy, pollution, climate change, global warming. We have n number of issues. But whatever it is, as I just now mentioned, we have been able to reach to moon. We have been advancing from 2G to 3G, 3G to 4G, 4G to 5G. Now we are moving upwards. All that we have done, ladies and gentlemen, that's fine. But now we are not being able to address basic needs: water, food, and shelter, and health. These are the four major components that one need to address. Otherwise, we will be in trouble. Right. Scientists across India or the whole world are totally engaged in design and preparation of materials. Water, how to make water potable. There's a big challenge. Purification, controlling the hardness, removal of toxic metal ions from the surface water or groundwater. Health, effective medicine, affordable medicine, effective medicines. There are some problems. We have been able to bring so many medicines. But let me tell you, ladies and gentlemen, I'll take this 1 minute to express my concern that all of us commonly take paracetamol, which is deadly, which is a toxic. It is a toxin. If you take paracetamol for more than 3 days, then you are in trouble. That's absolutely bad. Now, it was discovered in 1888, ladies and gentlemen. Till today, there is no replacement. There is a replacement for blood pressure, sugar, cancer, everything is a small drug, paracetamol, which acts as an antipyretic. It brings down the body temperature when you are, stuck with, fever. It brings down. Ladies and gentlemen, please note, since 1988, there is no replacement. What is it we are all doing? A shame on scientists. We have been not able to replace this. It kills people. During the COVID time, many people died. You can take me as a reference. As a scientist, I have my own way of looking at COVID-19. Many people died because of the heavy dosage of paracetamol, but not, COVID as such. It's not the infection. So there is what I intend to say. There need to be a systematic approach to replace this paracetamol with something else. Because I worked in the industry for 11 years, continue to work, that I wanted to replace the paracetamol with something else that's called naproxen. But it is not very successful. Likewise, there are so many issues. Well, come to energy. Now, if you want to realize, or if you want to realize the dreams of our leaders, Honorable Prime Minister, one need to work on energy aspects such as storage, generation, conversion, transport, and conservation. This all can be addressed with what are known as functional materials. I hope all of you agree with me that we have so many concerns, say a series of concerns, especially to the environment and you personally. Personal health, environment, personal health. We have been not able to address the concerns properly. I think if you come to Karnataka, there are so many villages they are deprived of pure water, drinking water. Forget about the usageable water. So many villages that are deprived of water. Then why we talk about growth of science and technology when we are not able to address the basic needs? That is my always bothers me, and I'm sorry that as a scientist, even I'm ashamed of myself. I've been not able to address, but I've been trying to do it. But my basic training is not good. I've been just do PhD for some sake, and I'm not able to focus on what need to be done. So this, what I request all my distinguished professors and researchers present here. Now let us go to primary school, train them what is needed by the country, how we can grow, how we can not overtake, how we can be self-sufficient. That can be done only when we go to children and teach them. This is what is being done elsewhere the world. Especially, I would like to take the example of Japan. Japan now it is in the forefront in terms of electronics or anything you take, because they focus on children, not higher education. Once you build the foundation, automatically it grows. If you take a child of who is 8th standard or 9th standard, they talk about electronics so well in Japan. Japan has been one of my favorite countries for this reason. There is a one leader and everybody follows. Now we are here scattered. All of us are scattered. We are not coming together. As a scientist, we are not coming together. Well, as an organic chemist, I have my own expertise. As a physical chemist, your own expertise. So we are not come together, ladies and gentlemen. This is a big threat to the country. We are not come together. We are not working together. This is the biggest problem. As a scientist, as a senior scientist of the country, this is my concern. And please, all of you, in the days to come, let us work together. Let us address our students and let us teach the lesson that we should come together and we should work together. Now, coming back to my, talk of the today. Well, right from the beginning, we have been working on soft materials, liquid crystals, and others. I don't know what happened. Okay, others. Those can be used for solar cells and so on. Our Center for Nano and Soft Matter Science now. Then it was Center for Liquid Crystals Research. It was established by Professor Sivaramakrishna Chandrasekhar, and I worked with him for 14 years. Professor Chandrasekhar worked with Sir C.V. Raman. I am very proud to say that I'm a part of our C.V. Raman family. I'm very proud to say that. Professor Chandrasekhar worked with Sir C.V. Raman, and I worked with Professor Chandrasekhar. So this legacy of doing good research is continued. I don't know whether how best I have done the research, but I would say I'm coming from the family of Sir C.V. Raman because Professor Chandrasekhar is a nephew of Sir C.V. Raman. You can see the two notes, they look identical. Professor Chandrasekhar, another Chandrasekhar won the Nobel Prize in physics from USA. And this is another Chandrasekhar who was nominated for the Nobel Prize on 3 occasions. Well, now we have been able to work on gels and LCDs. In the gels, we can work on, we can see generally whatever the LCD you see, that is organic molecule or you can say metal organic systems. But this can be replaced with the gels, organic gels. In the last 10 years, 15 years or so, I have been able to work on soft materials as well as nanomaterials. So we have been able to carry out a perfect marriage between nano and the soft systems, and there won't be any, kind of separation or divorce. This is a perfect marriage. Well, we have been working on different areas. I shall not get into this in the interest of time. So how much time is left, Professor, to me? Another 10, 15 minutes?
Yes, sir. Another 15
Please
minutes.
alert me.
Within 15
Sharply
minutes.
alert me. I don't want to bore all of you.
Yeah,
You're all
yeah.
highly distinguished, achieved professors. I don't want to bore you. I hope I'm not boring all of you. I hope.
No. Proceed.
Fine. Fine. And this, I'm expressing my concern, what I felt, because all of you are, such stalwarts. I should express my concern. That's what I made. Sorry about it. Okay, I'm working on different areas, conventional, conventional and non-conventional liquid crystals. I'm under the heading of conventional liquid crystals. So I've been working on different molecules. Look at the molecule. These molecules are extremely simple, but I have been able to, produce a n number of good research articles, including JACS and so on, many articles. Well, this is another sort of bread and butter. What we do is you take two organic molecules. One has one sort of functionality. Other is another. Let's say that it is a response to the light. The other is thermochromic. You join them together. You have an entity. You have one organic molecule that shows the dual properties. That's why I've been very successful. And we have been able to mimic DNA structure. What we have done is we have taken half disc-like molecule and joined them together through two amino acids. So we have been able to, address the concern of ferroelectric behavior in discotic liquid crystals. It has been one of the my favorite topics. Well, banana-shaped molecules in liquid crystals, it is very common. We use rod-like, cigar-like, chapati-like molecules, and this is banana. It looks like banana. We use banana-shaped molecules also. We say that. Well, we have been able to work on different organic molecules. That sense is, I'm very happy to let you know that I'm the perhaps the first Indian to be invited by. What happened here? Why this is not going? Top bar. This bar is not going.
What happened, sir?
Top bar. Why top bar is not going?
Stop bar. Oh, okay. Is it now?
Yeah, now it's okay.
Okay.
Okay. So I would say that I'm very happy to let you know that I'm the first person to be invited by King Abdullah University of Science and Technology. That I went on invitation. That they recognized my work and they asked me to develop a molecule that senses the H2S. H2 is one of the toxic gas. I think all of you know that many people would die when if they inhale H2S gas for a long period of time. Even if at the lower concentration, also there is a problem. So we have been able to come up with a device using organic molecule, and this has come as a one of the interesting inventions in the recent past. So it came as a front front cover, this work in Material Horizon, and if you are interested, you can go through that. And well, that is the one. Okay, I don't know why this is not allowing me to change the slides. Okay.
No, it was going on fine. Yes,
Okay,
yes.
fine.
Yes, we can
So
see.
now, as I said, we have been also working on coordination polymers, metal organic frameworks, polymers for energy, especially splitting of water and storage. We have been able to develop capacitors and supercapacitors. And using our coordination chemistry or coordination materials, coordination polymers, we have been able to identify toxic metal ions and toxic gases and explosives. And we have been able to generate composites for electrocatalysis. So we have been in the recent past, we have a number of patents. During the last 2 or 3 years, I have patented about 7 patents. I have accomplished. So I mean, this is a very interesting area. Well, this main area, main focus of my work is say energy storage and hydrogen evolution reaction and explosive sensing. I've been very successful, although it's a humble beginning, but I made some, some contribution, I think, and I need to grow. It's just, beginning of my career here. The second innings I have started, I'm started working, although I'm an organic chemist, but now I'm working on metals chemistry intensively. I hopefully I'll be able to contribute to some extent. Well, this is a flexible symmetric microcapacitor which we developed. In the sense, in the future, you can have a kerchief. In the kerchief, you are able to see the displays. So the COP that I have accomplished is inexpensive and it performs very well in terms of supercapacitor behavior. So likewise, we have been able to develop affordable cadmium 2 coordination polymer. It shows pseudocapacitor electrode behavior and hydrogen evolution reactions and so on. I think this is one of the best material we have in the world now. Now, coordination polymer used as a sensing of high energy materials, explosives, trinitrophenol, TNT, RDX, AN, CL20. You can see if you take our coordination polymer, let's say that in the three test tubes you have sugar, ammonium nitrate, and salt. If you add water, all are soluble. It looks clear water solution. Sorry, clear water. It's a solution of the three different solutes. But you don't know which is what, whether it's ammonium nitrate, if it's a sugar or salt. If you take our coordination polymer, put just a drop, less than a 0.001 milligram, it identifies. So this is what is being shown. And now we are working with the DRDO. We are trying to make device out of it. Thank you very much. And it's being patented. Well, this is, you can see, I'm blessed really. I didn't have any imagination that it would selectively, quench our coordination polymers will quench by mercury. You can see here, mercury is being quenched. Well, we have been able to isolate ZNO nanoparticles, which are very important. ZNO nanoparticles can be obtained from the plants, different plants. That's what we have shown. This has received a huge attention. It has lots of citations now. So likewise, we have been able to attain ZNO nanoparticles through different means, different plants. And okay, now coming back to my talk, and I'll finish in about 5-10 minutes maximum. Now, I would like you to look at this, video, and then will discuss about it. Now, I'm looking at. I hope I'm permitted to, have another 4 or 5 minutes. Professor, is it okay? Hello, sir. Sir?
Yes, sir. Yes, sir. Yes, sir.
Yes, sir.
Yes.
Yeah.
Yeah. Another some 5 minutes we can take.
Yes, sure. but 5 minutes doubt, sir. But maybe.
Okay, yeah. 5-10 minutes. Go ahead, sir. Yeah. Then, yeah.
No, I just, with the due respect to all you religion people, don't take it otherwise. I'm a very neutral. Look at this, some statement by a saint. Then you will understand what I mean to say. You are able to hear the sound, sir?
No.
Now?
No, sound we are not able to hear.
Sound is not. Can you hear?
No, sir. No.
No.
Only video is coming clearly,
Sorry.
but not the sound.
You're not able to hear the sound?
No.
No, unfortunately not.
Yeah, the link you can
but I
share
don't know
with
how to
us.
do it.
Later we can see that. Yes.
I'm getting.
Okay, we'll stop it because you are not able to hear. I'll not worry about it. Okay, now coming to the topic once again, I would like to show you a couple of movies and then we'll start. I don't know, maybe you have the same problem, but I think the movie is good enough to show you what I'm speaking about, all about. So can you hear the sound?
Not so. Yeah, start the video.
Now, can you see?
Yeah, yes.
Can you hear this?
No.
Can you hear the sound?
No.
Just watch it, sir. Just watch it.
Yes,
One
okay.
movie.
Okay.
ಮಾಡ್ತೇನೆ
ಬೇರೆ ಏಕ್ ಮಾಯ ಯಾವ ಏಕ್ ಮಾಯ
You are able to see the movie, sir, at least?
Yes.
Is it clear?
Yeah, very much. Why that bat is following him? Oh. Achha. So man is not seen, only bat is seen.
That is called invisibility cloth. This is real. It's not, any gimmick.
Okay.
Watch this movie. It's done at somebody's scientist at scientist home, and he used his daughter, son. Is one of my collaborators who has done this movie. Look at it carefully. Thank you. I hope it was very clear.
What is that film?
Yes, I'm coming back to that point. Okay, fine. So now I'll skip all this. You just one slide. See, in the movie of Harry Potter, the main character is working in the lab. Working in the library. You can see only his body. Only his lamp, and the lamp is held by him. Only that portion you can see, but not the person. In the next, you can see the moment that main character removes that gown, a cloth. Okay, so that cloth is something to do with light interaction, something to do with its characteristics. It is not the same material as we are, or you are, or the nature is. It is what is known as, such materials are called optical metamaterials. They do not interact with the light the way I or you or any object interact with the light. So it is something else. What is that something else? Well, as once again, as you or me or any object or any subject, when light falls on us, the light gets scattered and light gets reflected, or especially for the scattering of light, we are able to see things around us. This particular ground or cloth or sheet which is on the main character is something different. It will not, it is not the same, as it does not interact with light in a natural way. It interacts with the light in a very unnatural way. What it does is, question mark, I'll come back to that and look into the other, this thing. I will, right. So last 1 or 2 minutes, materials, metamaterials, there's something called new materials. They're called metamaterials. They are usually made up of metals and plastic, whereas for the first time, we have been able to achieve such materials through organic and inorganic systems, hybrid system. So metamaterials are basically man-made substances that have the properties not found in nature. Please note that they are man-made materials. Scientists have made these materials. They are not available in the nature. They manipulate light by blocking. Please note, blocking, absorbing, enhancing, and bending. They exhibit two important properties. That's what I told in the beginning. Any material you synthesize, they should show a couple of properties like negative refraction, epsilon near zero, perfect cleansing, and hyperbolicity. I'm working on E and Z materials. Now, this is the final slide. With this, I'll conclude my talk, and this, summarizes whatever I want to say. Well, I want, especially if children are there, if young scientists are there, I want them to listen to me carefully. So this is the first panel, left-hand side top. When wave hits natural objects, wave scatters, and thus object is seen, is quite common. In the second panel, down, left side, when wave hits man-made, metamaterials, wave bends, okay? Wave bends and hence becomes invisible. What do you mean by that? There is no scattering of light, there is no reflection of light. The light which is falling on optical metamaterials, they do not scatter, the light will not be scattered or it will not be, reflected. It takes a deviation. I shall repeat. The electromagnetic radiation, in terms of science, pure science, we call it as electromagnetic light as electromagnetic radiation. This electromagnetic radiation of visible wavelength, which falls in the visible wavelength, when it goes and falls on metamaterials, light is made to take a deviation, not scattering, not reflection. No reflection, no scattering, it takes a deviation, therefore that particular system becomes invisible. On the other side, right side, top, bending a pen image in water in one direction. So this is nothing but we have done this experiment when we were when we were kid. Now also it's very interesting. You take a glass of water, fill it half, then put a pen or a pencil or a straw. It appears as if the pen has bent. Ladies and gentlemen, it's not a bending of pen, it's a bending of light. Light is traveling from one positive refractive index medium to another positive refractive index medium. The air is thin, water is thick, therefore density, there's a difference in the density, therefore their light bends. Since light bends, the image appears as if it is bent. It's not the bending, it is a phenomenon caused by the light but not by the pen. So this is called the refraction of light. Ladies and gentlemen, the scientists have come up with a very interesting material where you can see when the same water put with something, you see the pen appears as if it is cut, because this particular material, water kind of a material, it has a negative refractive index. One good thing about cosmos energy or God has created, God has created n number of transparent material, they have positive refractive index. In the whole world, you cannot find water or diesel or petrol that has a negative refractive index. But if you mix it with optical metamaterial and make some experiments, one should be able to see this phenomenon. Okay, so that's how one can realize invisibility. Well, to put it in one frame, we have been very acquainted with visibility. We are able to see things around us very clearly. The extent of your eyes, the power of your eyes is so high. You are able to see things around you so well. It is because light is falling on all the objects you have or subjects around you. It's getting scattered and getting reflected. Therefore, the light comes to your eyes, and therefore you are able to see things around. This is called invisibility. When you talk about invisibility, although that object or subject physically present but not seen, this is called invisibility. This can be achieved if the scattering of light or reflection of light is stopped. I hope I made a nice present. I hope I'm able to convince you. But one of the experiment I should show you is that I should show you one experiment that talks about. No, I think it got, yeah. I'll show you my measurements, then I'll say. So this is one of the important slides. So this is shows epsilon near 0. This is the experiment we have done. We have taken about 1.5 years to achieve this. You can see it happens in the visible region. So this is the real and imaginary parts of the effective permittivity extracted from the PSI and the delta values obtained from elicisometry. So we have done beautiful experiments. So this is one of the best proofs, thanks to my physics collaborators, Gita Nair and Bharat. Amit is in USA now. Vimala is in Portugal, and they have done wonderfully well. See how you have achieved with a simple experiment. So this is a structure that makes that material to be like that. So let me show you. Yeah, this is a structure. So you have a self-assembled system because it's liquid crystalline. It has a material characteristics. You have dielectric array and conducting array, which are present in alternative way. So this serves as a epsilon near 0 value. And I take this opportunity to thank all my collaborators, all my students for joining me for such a wonderful work. And I thank all of you present here. Thank you so much for your kind listening. Thank you very much.
Thank you, sir. I think now the session is open for discussion. I think.
I request all of you not to worry. This is a discussion. We're all friends.
Yeah,
Not
no, kind of a
don't think about a silly
clarifications.
question or this question or that question. Please ask questions. Please ask.
Yeah,
Whatever
okay.
understanding I have,
Yeah,
I will try to answer to all of you. Don't hesitate, please.
Yeah, please unmute yourself and please ask, because as such there are
Anything.
no.
Don't think that is a trivial question. No.
Okay.
The discussion, it would help me if you
Yes.
give insight into my talk. Then it would help me. Well, first of all, was it clear?
Yeah, it is
Yes,
quite
clear.
Yes.
Well, Professor, it was a very good description of the things. Now, this metamaterial, what you are talking about, what is it? Actually, it is a soft nano composite or liquid crystals compiled along with this nano particles, or
Yeah,
what is
I
it?
think I showed you. This is the material. I'll tell you. I'll show you again.
Yeah.
So this is the material. Actually, you can see you have at the center you have gold nanoparticle, and around which you have organic molecules. So the outer side is dielectric regime. The inside, the central gold scaffold is a dielectric regime. Sorry, the conducting regime. So you have nice combination of conducting regime and dielectric regime. So this brings about that characteristics.
Okay, fine. So this is what is the metamaterial, because you have taken a lot of time in explaining that how the things are visible and how the things will become invisible.
Yes, sir.
Yeah.
Now, if I get into my if I go to my chemistry, it is really, I don't want to bore you. This is the way I have synthesized. Simple experiments. Take 2 test tubes. So you have gold. I'm talking about especially gold. So you have gold. See, you can see now I have taken gold in water, and there's a DCM, dichloromethane. DCM density is high. Therefore, it is the it's the bottom layer. My AU3 salts are in water. I add a phase transfer catalyst. So my AU3 ions walk into DCM because there's a phase transfer catalyst. Now what you do is the amines you have made. So these are the amines. You can see these amines. So you take these amines in DCM, just add dropwise. It's just Even I have taught BSc, PUC, or SL student to make this. I have gone to different schools. So you can make these metamaterials in grams. You can see this. These appear white, black material, but you can make very ultra thin films. You can see this property. I have shown here down.
Yeah. I got it.
Yeah.
Thank you, Professor.
Thank you, sir. Thank
Yeah.
you.
Hello.
Yeah.
Can you hear me?
Yeah, I can hear you, sir. I can hear you.
I'm A.N. Garg, retired professor from IIT Roorkee. I retired long back.
Namaste, sir. Namaste.
Namaste. I just wanted to know, is it only gold or there are some other metals also which can form?
Anything can be tried, sir. We have tried with gold because Indian tradition that we love gold. And it has a number of characteristics. There is a huge, there is something to do with gold and India. We have understood the nature of gold unlike any other countries. We have understood what is gold is. Okay, the important characteristics of gold is highly stable in the sense any structure you make, they are highly stable, sir. Therefore, we Indians are fond of golds, especially women. It's a sheer, not only it gives the social security, but also it has a number of properties. Gold being on your body, it is something interesting. It keeps you in good health.
No, but it is very costly.
It's okay, sir. Costly is okay. But what I intend to say, you can use any metals, any metal oxides.
Okay.
No problem.
I think all the noble metals, they might be stable.
Yes.
All noble metals.
No, it's just the beginning, sir. It is just my humble.
Silver, gold.
And is it always the tetramines or there are some other kinds of amines also which can form?
You are talking about amines, sir, amine?
Yes.
Yes. There are three functionalities which love to associate with gold or any particle, is that including quantum dots, amine, primary amine, carboxylic acid, and thiols.
Okay.
Only three.
Okay.
They gold get associated to that very strongly. They won't get separated out. We have done the experiment where you take a gold nanoparticle, take liquid crystal, and then try to add, there is a phase separation. Because these are physical entities we are mixing, which is not good.
And the sheet which you had shown in your film around that little boy, so whether it can be converted into some kind of fabric or some kind of, you say the t-shirt or anything like that, so to make the person invisible or?
Yes, sir. No, this is the ENZ property what I have shown. It amounts to that in the sense you make a thin film, thin film, and make a big sheet out of it.
Okay.
This can be done. In the since it is a forbidden area, we can't tell in detail. What we have done, we can't tell in detail because forbidden area, and it's very quite sensitive also. It can be used for many bad practices. So this is for only scientific curiosity we have done. People, as I said in the beginning, metamaterials, optical metamaterials are generally made by metals and plastics. First time we have shown that we can use organic and inorganic systems.
But can it be converted into some kind of fabric, say t-shirt or some thing? So
sir,
that
it already came, sir. In Mumbai, it came. T-shirts came, but it was withdrawn in 1 week. There are so many problems. People started using these T-shirts and pants. So the face is seen and legs are seen, in between is not seen. You can go to the literature and figure out. In Mumbai, it was marketed, and there are so many problems. You can go and check, Google or whatever it is. You will find that.
Very interesting information, and I congratulate you for such a nice presentation. And
I'm sorry, I'm very effective speaker. I tell whatever I know very boldly because I want something to be done for our country. I mean, we are basically, where all of us have failed in something.
No, probably in defense or in some kind of spying purposes, this could be very useful. So naturally, you are not supposed to make everything public.
No, it's already in the defense, sir. They are already in the defense.
Yeah,
I think all of you have watched that Indian movie that is Mr. India.
Yes.
Yes,
If I
this
remember.
concept was already there.
Mhm.
Okay, so this concept, meaning that we Indians know this. See, this is what I keep telling. We Indians know everything better than anybody. Let me tell you very proudly. Okay, Pushpak Viman we know, rackets. Okay, we know about, all of a sudden a saint chanting, mantras of his own or god or goddess. All of a sudden, Vani comes. Okay, uh, a devotee get up, I have come. He is not seen. After a few minutes, he is seen because the metamaterial he is wearing will drop it. So as far as now, the question is, I think I thought one of you will ask me, then what do you mean by God and Goddess? God and Goddess are special biomaterials, biomass. They use metamaterials. That's what my conclusion is. I may be wrong. You may think that I'm stupid. It's okay. But that is my way of looking at it.
No, that
All
is the
scientists
way.
are not correct.
That is the way you define.
Yes, that way I say God is existent, right? He's with you, with me, but they are wearing metamaterial. They are made up of metamaterial. Biomass is metamaterial.
Okay. Very nice.
What is that metamaterial? Extremely simple, extremely simple. Light will not scatter or light will not be reflected. It takes a deviation. That's it.
Yeah, I think maybe another one or two questions if there
Sure.
are.
Sir, myself, Dr. Anil Teyadal, Assistant Professor, JSS College, affiliated to Rani Chennamma University.
Sir,
Sir, actually, this
you are
gold.
not seen. I have to see you, see your face.
Okay.
Yes, sir.
Yes, sir. The gold nano, the properties of
This is
gold
not live. You have to
nanoparticles.
come live. This is saved. No, that I won't like. You have to interact with really.
Can it be visible, sir?
Put your
Now, because
video.
here power is not there, sir. That's why.
Okay, nice.
Ah.
So
Yes,
if
sir.
power is now
Actually,
you understand, if power is there, not there, you are not seen.
sir.
Light is not there, you are not seen. Fine, carry on. Just jokes
Sir,
apart.
actually, the properties of gold nanoparticle, they are competing with this carbon nanomaterial, sir. Carbon dots, sir, especially. These carbon dots are also having a very nice optical properties as good as this carbon, this gold nanoparticles. So, can it be possible to replace the gold nanoparticles core to this replacing with carbon dots?
Okay,
Because
I'll put
carbon
back that.
dots.
I understood, sir. Thank you very much. Sorry.
Yes.
I'll put back that ball to your court. Do you know that gold nanoparticles, silver nanoparticles, or any metal oxide nanoparticles show a wonderful phenomenon called surface plasma resonance? Yes.
Yes, sir. Yes, sir.
How about carbon dots?
Carbon dots are not showing. Yes. Those are not showing that, but still, this.
Wait. Don't go further. That's the answer.
Okay.
That's the answer.
Surface plasma
You
resonance
need,
is not showing with
surface
carbon
plasma
dioxide.
resonance should be there.
Yes, sir. That property is absent with carbon dioxide.
Yes, that's the answer, my dear.
Yes, sir. Because when it comes to this.
No, I don't know. You need to tell me.
Okay.
I want a nanoparticle that's capable of showing surface plasma resonance. At the surface, electron should be active. Let me complete,
True,
please.
sir. Yes, sir.
At the surface, electron should be vibrant.
Yes, sir.
Okay.
Yes, sir.
By the light interaction, the surface plasma resonance should happen.
Okay, sir.
On gold nanoparticle, when light falls, there is a resonance. Am I right?
Yes, sir.
That's the most important property of any given nanoparticles.
Yes, sir. Sir, one more thing with this transparency. So this the particles what you have shown is having some transparent properties also. Transparent properties.
No, sir. Please, as a teacher, you should not get confused. Transparency is something different from the invisibility. There is nowhere. I never said it's transparent.
Okay.
It becomes invisible. Transparency is another phenomenon. Don't club these two.
Okay.
That's why I said it should have clear thoughts.
Okay.
Yes, please.
Okay, sir. Okay. Thank you.
Thank you. Please, any other questions?
Yeah.
Sir,
I think,
want to,
no more questions. I think we move
sir,
on to the next step.
one question, sir,
No,
I
I
can
can
ask.
take one more question, sir, please. One more question. No problem.
Very nice presentation, sir.
Yeah,
Sir,
thank
I
you.
want to ask you only one thing. If I use laser in that metamaterial in monochromatic light laser is, how it will behave, sir?
Sir, I have not experienced. Very good question. And I would like to collaborate with you, sir. Take our material and try to do something.
Sir, I am
You are
from
welcome.
research scholar from NIT Surat Kal, sir. I will contact you, sir.
Yeah, please, please, please.
Thank you, sir.
बहुत शुक्रिया. मेहरबान.
Shukriya, sir.
शुक्रिया, शुक्रिया. I know you personally, right?
No, sir. I am under Dr. Shashi Bhushan Arya, sir.
I know, yaar. I have come to that place often.
Welcome,
I'm
sir.
a mad person. I'll be called by many people.
Yeah. Okay.
Welcome.
Yes, yes.
Okay. Oh, you agree that I'm a mad person, right?
No, sir. What you are telling?
You know, if you want to do good research, you should be mad, sir. You should be mad.
Recording in progress.
So there are
Next,
different
we would like
ways
to
of
IS.
interacting with. Sir, one more thing. There's
Yes.
different ways of interacting with all you distinguished scientists. I have a number of topics. I work on liquid crystals and Nobel Prize winning chemistry aspects. So many aspects are there. I would love to interact henceforth, all of you.
Good.
And one last this thing suggestion is I request all the distinguished professors and researchers to go to the primary school, teach our children what is to be done. What are the problems? What is to be done? Encourage them. That is my real humble request to all of you. Go to the schools. I do that. So far, I've given 1,400 lectures. So far, I have addressed college students, especially primary school children. I go with models. I make them to understand. So that is a kind of
Outreach,
sensitivity you should
outreach
have.
activity.
Yeah,
Good.
sensitivity you should have. I
Yes.
think Professor Manjana agrees with that. I'm very forceful speaker, and I won't be. Yeah, very
No,
very.
no,
forceful.
sir. You have made a nice presentation.
Yeah.
Thank you very much, sir.
Let us all go to schools. Let us
Yes,
all
yes,
go to
yes.
schools.
Yeah.
Train our children so that we see bright future, bright India in future down the lane.
Yes, sir.
Thank you very much.
Sir, actually, yeah, ISAS is very happy to, award you, say, excellence certificate of excellence award. I request our Honorable President Dr. Raghav Sharan to virtually hand over that. Before that, I would like to share that certificate and read out the citation. Just hold on, sir, for a minute. Yeah, I'll share that certificate of excellence.
Thank you very much. I'll put it in my status. It's one of the the highest recognition I ever got. Thank
Yes.
you very much.
Yes, sir. Yeah.
And I'll be coming
So
to
I would like
Belgavi
to,
for the conference. I'll be presenting.
I would like to read it. So, Certificate of Excellence in recognition of the excellence in research into the exceptionally relevant and useful technologies. ISAS is happy to confer this Certificate of Excellence and Relevance to Professor Dr. C.V. Yelamgad, Scientist, Center for Nano and Soft Matter Sciences, Bangalore, for an insightful talk titled Functional Soft Nano Composites for Invisibility and Other Applications. On 13 September 2025, during the talk, Dr. Yelamgad shared his immense insight, expertise, and enriched knowledge on subject, the functional soft nano composites. The talk delivered in the webinar series 2025 organized by ASAS in association with ASAS Belagavi chapter and Rani Chennamma University synergized immensely with the objectives of ISAS in promotion of science and technology. So I would like to request our Honorable President to hand over the certificate virtually.
Thank you, sir. I
As a
received
mark
it.
of
Thank you, sir.
appreciation, Dr. Professor, I want to hand it over to you. And
Thank you,
I am really interested with your concerns and all that concerns which you showed, potable water and agriculture and food and all that turn by turn. So that shows actually the worry of real scientists and
Yeah, thank you,
practical
sir. Thank you, sir. Sir,
Yeah.
I fight like anything because
Yeah,
I
yeah,
go to
very good.
schools, ask for their time and teach
Yeah,
them.
we do very big things. It
Yes,
appears that we do very big things,
yes,
but
sir. Yes,
unfortunately, we are not able to address these little things.
yes, 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 sir.
Thank you.
Thank you, sir. Thank
Yeah.
you. I'm
As a,
happy to
no,
receive
just
this.
for the
I'm
final
happy to receive this,
step,
and it's a
I
great honor
request
for me
our
to receive this.
the secretary of our ACS Belagavi chapter, Dr. Prasanna, to propose vote of thanks. Dr.
Thank you,
Prasanna?
sir.
Yeah.
Sir. Thank you. Thank you very much, sir. Good evening, everyone. As a secretary of ISAS Belagavi chapter, it's my duty to thank the speaker and all the participants. So, first of all, I would like to thank El Maggas, sir. Because, yes, that's why I'm pronouncing it properly. Because
No,
Manjana sir
no.
also made a mistake.
Yeah.
Maggada, Maggada.
Maggada.
Not la.
Because I was also
Ed Maggada.
Ed
Ed Maggada.
Maggada.
Ed Maggada. 7 looms.
Looms.
That's
7
amazing.
looms.
Yes. Yeah. Thank
Gadanta
you very much.
ಸಾಕಪ್ಪ ಗದಾಂತ ಕರಿಬೇಡಿ ಅಷ್ಟೇ.
ಇಲ್ಲ ಸರ್ 7 ಮಗ್ಗದ. Sorry, sir. Thank you very much for your very informative lecture. You made us to visualize the invisible things.
Yes.
Thank you very much, sir. Thank you very much for taking your time to enlighten us about soft nano materials and their invisibility properties. On behalf of ISAS headquarters and Belagavi chapter, I thank you, sir.
Yeah.
And
thank
I
you very
thank
much.
the president of ISAS headquarters, Dr. Raghav Sharan, sir, and chairman of webinar committee, Dr. P.V. Joseph, sir, and chairman of ISAS Belagavi chapter, Dr. Manjana, sir, and Dr. Padmara Sali, chairman of Department of Chemistry, RCU, Belagavi, and all the chairmans of ISAS various chapters, office bearers of ISAS headquarters, executive council members, and one and all who are present in this webinar. Thank you, one and all. Good night.
Sir,
Thank
you very much, all of you. One small thing announcement from my side.
Yeah.
Anybody calls me for any lecture, I'm there. Don't worry about money, my transport, everything. I can even come by cycle. There is no problem. Money is not a big deal. My
Very
concern is only for the country. So
Very
please
good,
call
very
me.
good.
I think Ramana is here. Ramana, together we have worked, Ramana. So we have worked a lot. So we have gone to the schools, we have done. Anybody, even village, Kittur village also, I'm ready to come and deliver talk. I'll reach to the students, I'll win the heart of students, and I'll tell them what is all important, what to do, how to make India shine. That is my big concern. I think all of you will join me. Give me an opportunity to interact with students, fellow students. They are bright. We can win Nobel Prizes. Thank you.
I can't stop telling that you are weaving your topics wonderfully, being an expert weaver.
Yes,
My
sir.
35 years of dedication is all making it, sir.
Yeah.
Yes, sir. Thank you, sir. Thank you
Okay, then.
once again. Yeah.
Good night,
Shubharatri
everybody.
for all.
It was a
Shubharatri.
pleasure to talk with you.
Yes.
Yeah.
Can I log out?
Recording stopped.
Yes, sir. You can log out. Yeah.